I will give a quick introduction to Napari and the Napari Assistant. And what I like to show here at the very beginning, it's one of the very first screen recordings or videos I made of Napari when I was analyzing this trivolume data set. It's like a developing embryo, like light sheet data over time, quite some gigabytes large, and I can interactively, maybe I also start it again to show it again. I can interactively go through this volume and tilt it in space and turn on and off different views of the data and the connections between the nuclei and where the cell is segmented and so on. This is stuff I always wanted to have, like when I was working with ImageJ before as well. And this 3D interaction was really something that was like not available at all in the ImageJ ecosystem. You have like plenty of windows on your screen, and it was kind of confusing if you had more than 5. And Napari with this layers here on the left brings kind of order into this and allows to interact with 3D data. And now that microscopy is like, at least in my local environment, mostly 3-dimensional, I'm very happy that we have this kind of viewer available for interacting with data in 3D. Just in very brief, this is the Napari viewer. I think most of you have seen it now. You typically have on the left side configuration tools where you can, for example, tune how the current visualization is shown. You also have this list of layers, and you can also add more layers there. And I will show in a second also why this is necessary. And this is Napari core basically, so that's what Napari brings with itself. Oh yeah, and the viewer control for changing how stuff is visualized. And then here you have on the right side so-called doc widgets. What we, for example, know in Napari is kind of dialogues, where like another window pops up. In Napari, typically, you see these windows on the right, snapping into the main window, and we differentiate doc widget and function widget. So a doc widget is like with different buttons and stuff. They can look arbitrary. Function widgets typically have pull downs where you choose parameters. So here, for example, I have to choose a label, image, and operation, and I have to enter a number n here. Just as one example shown. So typically you have the core Napari stuff on the left side and the plugins which are inside, which you are using on the right side. And depending on what kind of image you look at, so you see here on the left, this is an intensity image. And on the right, you see when a labels layer is selected, so a segmentation result, then these tools look differently. So you see here on the left, I can change contrast limits to change how bright and dark the image is visualized. It does not make much sense for segmentations. But for segmentations, you may want to change the brush size, and you may want to draw some additional annotations with a different size. And therefore, you see different tools on the right side. Also note these buttons here on top allow you to interact with the current layer in a more detailed way, like drawing annotation or going back to a zoom in mode. I will show that, or we will do this together in action in just a minute. And then there's a couple, I guess that's the video. There's a couple of things in Napari, let's call it things for now, which are not super obvious. And I quickly want to show them at the very beginning because I have seen quite some people struggling with that. So here you see, for example, this is like an image where I have 3 channels, but I have a slider to go to the left, to the right, and I actually would like to see these 3 channels at a time. So there's a right-click menu on this layout menu so that you can split this 3-channel image, which is visualized as a spec, into 3 individual channels and then visualize them separately. So this right-click menu, maybe I just show it here again. This right-click menu also has some more tools, like for example, converting an image to a label image or converting a label image to a normal image spec. These kind of tools are not super obvious. It's the right-click menu on this layer list, and that's why I'm showing it here. So something you do if you interact with Napari and learn everything by yourself, you learn this quite late, and that's why I wanted to highlight it here today. Also super hidden, unfortunately, is this right-click menu or this right-click window on the contrast limit. So you can change the brightness contrast. So we also know this from ImageJ, for example, to increase the visibility. But sometimes you may want to enter numbers. You may want to enter a specific contrast range. And this comes with a right-click. And then you get this additional window where you can actually enter numbers. Also, I learned this quite late. That's why I'm showing it here today. So if you want to, for example, you open 2 images from a microscope where you know the intensity range is identical and you were like imaging the same sample just in 2 different regions, some scenario like that. If you want to make sure that it's really visualized the same way, right-click on this contrast limits range, And then you can enter precise numbers. I want to see this image between intensity 1000 and 7000. And then you can be sure that the intensities between these two images are comparable. Furthermore, if you want to have this even more in detail, even more control about that, you can also use this tool. It's a Napari plugin now. So you see here on the right this time, there's this user interface, which allows you, for example, for both the selected layers now, to tune the visualization in a way that percentiles are shown. So I want to see my image between percentile 1 and percentile 99. So I want to see most of the intensities nicely distributed within my histogram. So for tools like that, there are then custom Napari plugins because Napari core does not bring this functionality. So this one here, you would, for example, find in the tools visualization brightness contrast menu in the Napari, which is installed on your computers, which you installed in the session earlier today or even before. Good. I quickly want to guide you through manual annotations in Napari because it's such an important topic. We should ideally immediately do this together. So imagine you have Napari open. You see your nuclei in front of you and you want to annotate something. You can use this button, which is marked there, to create a new labels layer. So you see then that it's a new label entry in the layer list popping up. And you can there choose the pen tool on top, or the brush tool on top, and you can then start drawing. And when you want to, for example, annotate 3 different nuclei with 3 different colors, with 3 different IDs, 1, 2, and 3, you should use this plus button there in the user interface. And I think I will quickly show this, and I was actually thinking or hoping that we can do this together. So I will do this very, very slowly. And the colleagues in Garda-town stop me also if I'm too fast. So please all open a terminal if you don't have it yet and activate the environment. This will be on your computer, maybe a little bit different than on mine because I enter conda activate. And I think the command, maybe somebody from the others can help me, is like Mamba Forge activate in your case. And then we start Napari. And here I will wait a minute because Napari sometimes starts a little bit slowly. And I here will wait a minute for others to catch up. Also, if you have a question, it would be a good opportunity to ask now because I will just wait until Napari is open on our computers. Please open the example image blobs from image J, which you should find in this folder, in this menu, in this submenu. So we now see in front of us maybe the most ever analyzed image because we show it in pretty much all trainings sooner or later. And what I was mentioning earlier, so here you see brightness contrast. You can visualize how this is. You can change how this image is visualized. You can also change the lookup tables if you want to see it in a different color. This is typical things you find here in this particular region. Again, when you right-click here, you can fine-tune very precisely how the image should be shown. Just that I just quickly remind you of this nice tool. You also, when you hover with your mouse over it, it also gives you the hint. What I now would like to do together with all of you, I would ask you to click on this new labels layer button here. Maybe I make full screen. And then we can start annotating stuff. So this is the brush tool, which allows you drawing. And you see that this is a quite large circle for this kind of image. I will show you in a second how we do pixel classification in Napari. So that's machine learning. And there the recommendation is to use a rather small brush. So maybe 1, maybe 2 pixels, but not such a thick brush as it was configured before. And then we can, for example, we just grab one of those blobs here randomly and we draw a line around. And then we increase, as I've shown you on the slide with the plus button here, we increase the label which we are drawing. And then we draw another something into this blob. Doesn't have to be super precise, but it is important to basically guide the computer in. We want the pixels at the border are part of the blob, and the inside is also blob. We basically, for a machine learning tool, we want to tell it how to differentiate the blob, the blue, from the not blob, from the brown outside. If you have never used this tool before, you can also see in the very bottom left of my screen, it says there are labels 110, 101, and then :2. This 2 is the intensity where my mouse is currently located. So I see here I'm hovering over this blue thing. This has intensity 2. It's the label 2 I'm annotating. And here, if I hover with my mouse over here, it's label 1. And when I'm outside, it has label or intensity 0. So nothing is annotated here. That's why it's 0. This is label 1. This is label 2. And if I switch to the blobs image, you can see actually proper intensities here. So you see this is like varying between 60, 100, 200, depending on where I'm pointing at with my mouse. So you can quickly basically inspect roughly what kind of intensities exist. So I have to quickly move some windows around. Good. And then I would like to ask you, after you have annotated these two things, go to the segmentation labeling menu and you find the object segmentation there, ad hoc. You should now see such a window where you, for example, can select the image you would like to process and a ground truth annotation. And here, this ground truth annotation is the labels. It's the amount of selections you have here now are not many. That's why it's still easy. So this pretty much a tool like in ImageJ, we call it WK, trainable segmentation. Some people know Elastic. So this kind of machine learning tools for training a random forest classifier, for identifying objects, for differentiating foreground and background here in this case. So when you have this tool open, select the image here, which should be processed. And in this pull down, please select your annotation you have been drawing. And when you click on train, it should, after a second, come up with a segmentation. So this is a very common use case of how people use Napari. You annotate something by creating a new labels layer, by drawing on this labels layer, and then you start a plugin. Here, in this case, I showed you ad hoc, but you can also use other tools which then take an image and an annotation and do something with it. I will just show another step if you want to follow me here, not super necessary, but I will just show another step. So we should now clean up a little bit what we look at. We see here the original image is below. You also see there are our segmented objects on top. I also see my annotation still. I don't want to be super confused. That's why I, for now, hide my annotation. So I click here on this eye on the labels, and you see how my annotation is disappearing. And I'm now creating another labels layer on top. And maybe I also rename it this time. For example, I want to do, and later I want to classify my object. So that's my object annotation. And you can rename a layer by just double clicking on it. So here it's this editing tool popping up. And I now annotate again on top of my object. And this time, again with the brush tool, the size doesn't matter so much. I'm just drawing here a line through these elongated H-shaped objects. So I'm basically marking these objects with an annotation I am drawing. Furthermore, I'm now increasing again the label to draw with a different intensity again. And I'm now here drawing a little bit on top of these objects, which are more roundish. I want to train a classifier which can differentiate elongated H-shaped objects from roundish objects. That's the goal. And we close this object segmentation thing. And in the segmentation post-processing menu, which is on my screen super big, we want to do an object classification. I will again wait a second, hoping that you can follow. So that's it. So then such a window again should pop up. And this time it asks you also here, I would like to process an image. So there's just a single image we can choose. The labels here in this case, the object labels, is the result of the object segmenter. So we should here choose this one. And my annotation down here should be my object annotation. And this is here the point now. If you rename these layers to names which you can later recognize, so I call this one object annotation, and I then was drawing an object annotation in it, then in these pull downs, it will become quite easy to find the right thing. If they are called labels 1, labels 2, labels 3, labels 4, you may have a hard time with these user interfaces to find the thing you were thinking of. So try to have labels layers when you open images, when you create new labels layers, give them good names so that you then later have an opportunity for choosing the right thing and not mixing up stuff. As features for the classification, I'm not so much interested in the intensity, but I'm interested in the pixel count and the shape. When I then click on train, I should get a differentiation between the H-shaped elongated object. So this is also elongated a bit. Yeah, I kind of agree. And the roundish one. And it's not perfect. You see here, for example, there were two H-shaped objects which were not like classified correctly. So I could now fine-tune this object annotation. We could also play with these parameters, but we are not talking about machine learning today. I just wanted to show you how you can deal with these labels layers, how you can hide and show these results, how you can change the visualization and these kind of things in Napari. So just as a basic example of what we do with Napari when we interact, for example, with images, with annotations, and then with plugins for creating more stuff. Are there questions so far before I go back to my slides? I would recommend, it may now sound weird, but I would recommend if you do one thing with one image, open in Napari where you only do that. Because if you have multiple different images open and then you ask, for example, to create a new labels layer, that's what you might have done. Then Napari is confused. How big should the labels layer be? Like the first image or the second? That's why it's maybe that's because it's still under development. I'm not sure. But within one Napari window, only do one thing. Good. Then I will just return and I will show you some more Napari plugins. So we cannot go through them all and look at them in very detail, but I would like to highlight some. I think Napari-animation was maybe the first or the second Napari plugin ever made. And you see here how I'm interacting with a data set and I have a segmentation and I'm basically going in space and in time. I'm moving back and forth and I click again on this capture button. Maybe I also show the second half of it again. And I click again and again on this capture button to create keyframes. This is very similar to what people know, for example, from Imaris for generating videos, for generating animation. So when I'm done with that, I can save, for example, an MP4 file. And then afterwards, there will be a nice rendering of this interaction I just had with Napari in the video. So that's why it's certainly one of the first Napari plugins, and I would also say one of the most popular ones, because by just zooming in somewhere in your sample and clicking on capture, and then zooming out again and clicking on capture, you get a video which zooms in and out to a specific region in your sample. So if you quickly want to show a little bit context around your three-dimensional object in your microscopy image, this is a super useful tool in order to make nice visualizations, which you then, for example, can embed in PowerPoint. Then there's this tool we programmed at some point also to have like stuff which we knew from ImageJ. You can here draw a line in your sample and you see the intensities along these lines. And then you can turn off and on layers like I've just shown you in the practical before, to also tune what intensities are now plotted in this plot, right? These kind of things are not part of Napari core, like in ImageJ was part of ImageJ core. Here we have to make plugins for these kind of things to have this kind of functionality available. Also, what becomes quite important nowadays, let's see if also this video works, is interacting with image data which exists somewhere on the cloud. So here locally in Dresden, Marcelo had set up an Omero server for us and also supported some tutorials. And here you see a video where I'm logging into our Omero server and download the images I presume Marcelo was uploading at some point. So interacting with data which is somewhere remotely located is something I think will be in the future more important. And we are very glad that people program these plugins. So this one is from Telly Lambert, who will be here by the end of the week, maybe, as far as I heard. So it's super cool that basically these kind of tools are programmed by people around the world and then we all can use them. Locally here, we also had the issue that like the Omero server was not immediately like working. And that's why we also developed a plugin for the own cloud that you can log into an own cloud server, inspect your image data. You can also segment these images and then upload them to your own cloud. So it's kind of maybe not the best way of interacting with microscopy data. I would love to do these things with Omero, but with your own cloud, it's also possible. It's also just a plugin you install into your Napari. The Napari filament annotator, I think that's a very young plugin, allows you to annotate objects in 3D. I also showed this video again. Typically, you always look from one particular perspective, like the one here. And if you tilt the perspective and draw again, you can actually define a three-dimensional line in space. So that from a user interface perspective, a super cool thing. Seriously, in ImageJ, completely unthinkable. And again, that's why I'm glad that we have these kind of tools available in Napari. One tool I also programmed quite early was Napari segment blobs and things with membranes. So the name of the plugin describes actually what it's doing. And it has a lot of functionality from scikit image. And it's basically, I made it in order to have like the basic things we love from ImageJ, a Gaussian blur, a median filter, threshold, Otsu, these kind of things, to have them available in Napari as well. So there's like no fancy deep learning or anything. And this tool is just image processing steps in menus, and the plugin is called Napari segment blobs and things with membranes so that it can be found. Then colleagues from Milan took the noise to void algorithm. Joran Deschamps was the one leading here in Florian Nuke Lab. Took the noise to void segmentation algorithm, segmentation denoising algorithm. It made a Napari plugin for it, which is also extremely user-friendly. You see here how the training is happening over time. You can then also here click on the tensor board and see more in detail what's happening in the background. And then, yeah, of course, you can basically save this model, this deep learning model, you can save it to disk and then apply it to other data in Napari or outside Napari. So that's very, very cool to make this deep learning technology available in Napari as well. Oh yeah, here my animation is screwed up, but that happens. So cell posts and status, I guess many of you have heard before, are deep learning algorithms for segmenting cells and nuclei. I think it's mostly thought for that, but also very powerful. And also for these two Napari plugins exist, which are, I would even say, community maintained. It's not just the developers of these two tools who basically make this in Napari available. It's a larger community who takes care of these. I heard some noise in the background. Was there a question? Also, something I was dreaming of for quite some time is working with point clouds and surfaces. It's also something we have never seen to a larger degree coming up in ImageJ, but in Napari it was more at hand, so that you can, for example, do masking cubes, a reconstruction of the surface of these objects, and then interact with these kind of surfaces. For example, you can here smooth surfaces, you can measure properties of these surfaces locally and then visualize it in color. Here, Zach Marin and Johannes Dolzviertel were super helpful colleagues who maintain also more plugins in that direction. So I think it's now 4 or 5 plugins altogether, which allow you to process points and surfaces, and this just shows one of them. Here, that's also, if you want to know a bit more what Marcelo was working on recently, we had this problem in many projects that people came and said, we would like to measure things inside things. So we have like, we have cells, and in these cells, there are some granules, and now we would like to know the average granule size for each cell. This is a very common task here on campus. So plenty of projects arrive where these kind of things are necessary, and it's super hard to generalize that. So if you could theoretically all the time write a new ImageJ macro or a new Python script for solving these kind of problems. So Marcelo took the challenge to program a user interface for that, which is very interactive and allows you to tune the situation, what you want to do. What kind of summary do you want to do? Do you want to measure the intensity of these things or just shape? And then how do you want to summarize the shape? These kind of things are very conveniently done in this Napari plugin called Napari Scikit Image Region Prop. I think it's also one of the most often used ones, also one of the oldest plugins we maintain. Basically doing feature extraction. If you want to do feature extraction, in particular when you work with 3D data, I would also recommend a Napari plugin called Napari Simple ITK Image Processing. And Simple ITK is a Python library built on top of the Insight toolkit. That's where this ITK comes from. ITK itself is now something like 14 years old. Maybe the oldest image processing library on this planet, comes from the medical field. And there is like medical products like tomographic scanners basically built with this software. So the quality assurance behind ITK, behind this software library, is super high. It's super well, basically super high quality software. And Simple ITK is built on top, and Napari Simple ITK Image Processing is the Napari plugin built on top. I would trust this measurement library the most, in particular when you work with 3D data. Again, high quality. Then there's also a thing which just came up something like 3 months ago, Napari-Nexus. Napari-Nexus is also a feature extraction library. I would presume maybe a bit focused on 2D data, but I'm not exactly sure. And also this is like in development, or they are just done with development. The cool thing about this library is that they come with something like 400 features you can measure. And it's basically the best. These features are known from Scikit Image, from ImageJ, from Site Profiler, and from other tools. So they basically put them all together in one tool, in one library called Nexus, and then build an Napari plugin on top of it so that you can interact with it. For example, if you do some unsupervised machine learning, Marcelo will show you later during the week, if you do unsupervised machine learning and you want to know which of these parameters or which measurable feature, which measurable parameter of my object tells me actually something about my phenotype or allows to split the groups into the cells, the nuclei into multiple groups, maybe Napari-Nexus is the way to go because they have most of the features implemented. So that's also very cool to see that people spend dedicated efforts on exactly that. All these feature extraction plugins have in common that you basically the result is a table, and you can interact with this table like you see here. So you can click on table entries to visualize which object it was in Napari, but you can also click with I think it's this tool which is selected here, which I don't know the name, but you can select with this tool, you can basically select object in the image, and then you see which entry in the table this corresponds to. So this also kind of interaction you always want to have an ImageJ, and I think they're not yet there. Same tool, also here, just different feature shown. You can double click on these table headers to generate an image where the measurement is visualized in color. So that you, for example, see here that in this region, this particular parameter is a little bit different than in other regions. So there's like a color coding of these parameters. Just by double clicking on the table headers, so like no need to program a script for that. You just have that available in Napari. That's the unsupervised machine learning part. Just like a little preview of what Marcelo will show you later, I think on Friday. So you can interact with your measurements and visualize the regions where these measurements, these data points, where they are in your 3-dimensional data set. So you can see what measurement belongs to which cell or which nucleus in this case. There's also super crazy stuff ongoing out there. So I mentioned Loïc Royer already earlier. It's a group leader in San Francisco and also founder or like one of the core developers of the very first days of Napari. And he was like recently, he brought out this Napari plugin. He calls it a weekend project, but he also said that it was multiple weekends or maybe even some weekdays on vacation. And what he is basically doing, I also play this video again. What he's basically doing, he is interacting with ChatGPT, with a large language model, saying, can you please make a widget that allows me to segment objects in this image? And that's what it does. It generates Python code, which basically allows him to segment these nuclei in this image. So that's pretty mind-blowing. Many people talk about what large language models, what AI will do to our society, and this plugin is, I think, a very good example of how image analysis may change in the coming years. We will most likely no longer sit there and program code like this threshold Utsu and connected component labeling. We will most likely less and less program these kind of things. And an AI will program this code for us, and we will just copy paste or even like here, immediately generate a plugin, a widget from that, and then interact with it. So this basic programming stuff will go away. Because of ChatGPT, and Napari ChatGPT is one example showing how you can exploit that. There's also some more, let's call them tools available. So if you, for example, want to know a bit how you can work with key interactions or more or less anyway, like updating visualizations in Napari according to a measurement over time, or using the keyboard to control something, I can recommend you having a look in Napari, a Napari plugin, which is not 100% serious, but still fun to look into the code and work with it. Good. The era of Napari plugins has just begun. I'm not sure how many we have now, something like 300, 350. And a year ago, it was like 100. I'm afraid we will have 1,000 in a year or maybe 2. This is also what happened in the ImageJ ecosystem. Also there we have now thousands of plugins, and it's hard also to keep an overview. And There's like many plugins doing the same thing, and it's like a bit tricky to keep an overview and to know which plugin is good for my particular data. And therefore, the Chan Zuckerberg Initiative invested a lot of time, a lot of effort into the Napari Hub. It's a website where you can search for plugins. I always recommend, for example, entering biological terms or going in a bit in direction of biological terms. For example, if you want to do cell segmentation, enter cell segmentation there and see which plugins provide this kind of functionality. And if you are a plugin developer, make sure that your plugins are found when, for example, biologists enter biological terms. You also see here feature extraction. There's like 8 plugins. I guess now it's even more. The screenshot is a little bit outdated. So there's like a search functionality for plugins. And also within these plugins, you can have a quite detailed look on what happened to these plugins. So you see here in this window, you can click here on activity, and this second window or this kind of other screenshot will pop up. And you can then read a little bit about the history of this plugin. So you see this plugin has been downloaded or used 14,000 times, and it was publicly released 2 years ago. So this is like an established old Napari plugin, presumably still works, and you can use it. Also, in the last 30 days, it was downloaded 650 times. That's a good sign. People download it, people use it. You may want to try this one out over one plugin, which is like 1 week old. It was downloaded 5 times, right? So that's one hint. But also it's kind of the opposite direction of the hint that you see here on the bottom. The latest commit to this plugin was done 2 months ago. So for 2 months, nobody changed anything in it. This can be a good sign, like in a 2-year-old plugin, when nobody worked on it for 2 months, that might be fine. And you also see it here, yeah, they were working on it half a year ago. Yeah, at the moment, nobody's working on it. But if you find a 3-month-old plugin where the last commit was 3 months ago, it's possible that developers do not work on it anymore. It was the first attempt, it was a test, it was something trying, but they are not actually maintaining it. So that's what the second activity page is meant for. You can see here a bit how actively is this thing used, how actively is this thing maintained. And that actually shrinks down. So for example, if you search for a specific task, I want to do a segmentation of whatever, and you find 3 or 4 plugins, you can maybe exclude 2 of the plugins which are obviously not maintained or were obviously never used by anyone. So and then you maybe want to use rather these plugins which are downloaded by a couple of people and which are actively maintained. So this page can give you hints in a direction of what you may want to use. So I promised at the very beginning I will introduce you to Napari and the Napari Assistant. So the Napari Assistant is also just a Napari plugin, but it's a plugin with multiple, let's say, sub-plugins below. And the goal of this was, instead of like, we have an image data problem that menus and submenus are full of stuff and it's super hard to find things. That's why we were trying to build a user interface which still has a lot of functionality available, but the user interface is more intuitive than a menu with submenus, and the assistant was the result. And you see here in the middle, that's the Napari Assistant, and on the right is the basically blueprint we had. We wanted to make a pocket calculator for processing images. So that was the goal. And you see here again on the left side, the viewer controls normal Napari, and on the right side, you see these 2 windows are the Napari Assistant. I quickly show you in action. I also would like to thank at that point Ryan Seville, who was working in my group back in the days, is now a PhD student at the MPI-CPG. And he is basically interacting with data by clicking buttons on top. So now he wants to measure something and visualize this measurement. So interact with buttons on top to add new functions, new operations to an image processing workflow. And sometimes you also configure a bit the parameters on the bottom right. And I will show it in more detail in the following slides. Yeah. And if you wonder why are the buttons so big, the buttons are so big so that you can use this tool from a touchscreen. Like, for example, I'm using it here on the big touchscreen in our former office. So yeah, interacting with 3D image data on the big touchscreen is also fun. I can recommend. Good. So this is basically what you do. So I was here clicking, I had my blobs image open, and I was clicking on the remove noise button here on top. And then you see here on bottom in this operation pull down, you can select multiple algorithms. For example, there's like the Gaussian blur from simple ITK, the Gaussian blur from scikit image, and the Gaussian blur from Esperanto. So different image processing libraries which have Gaussian blur implemented. And there's also median filters and the mean filter, and not every filter exists for every library. Not every library provides every filter, so you find them here all in one pull down. If you have a good computer in front of you, they will all work. What we sometimes see, for example, with old Mac, Esperanto may not work, simple ITK may not work, but Scikit image works. So if you are on a computer like this, you may have to choose this algorithm because the other two don't work. So this is kind of, I would love to fix these kind of bugs, but it's kind of unavoidable that with multiple operating systems, different Python versions, different Napari versions, and so on, a subset of available functionality, a subset of installed tools will not work under all circumstances, unless you have a very fine-tuned operating system very close to what developers use. And yeah, the older a computer becomes, the less likely it is that everything still works. So then I was here selecting, I was clicking on the binarize button, and I see these different thresholding algorithms. And also here again, you see the triangle method is implemented in Scikit image. It's also implemented in simple ITK, O2 multiple thresholds in simple ITK, O2 in Esperanto, and so on. So you can, from this pull down, you can choose different operations which may or may not deliver the same result. And then I was clicking on the label button to, for example, select the connected component labeling algorithm from the Scikit image library. And this is how you build up a workflow. So you see here on the bottom, the blobs image was there before. I applied a Gaussian blur, I did threshold also, and then I applied connected component labeling. And then I have basically shown these 4 layers with these 4 intermediate results. I've shown them in Napari, and I can hide and show them again. And in that way, interact with my image processing workflow. So I'm setting up a workflow without writing a single line of code. What is also kind of necessary in this context to mention is the tools menu. You have already seen it in the exercise before. Also here again, you find, for example, the different Gaussian blur implementations from these different libraries all in the menu. So that makes this menu a little bit full, unfortunately, but it is what it is. And I hope that the different categories like filtering background removal, filtering noise removal, filtering edge enhancement are better categories than what we know from ImageJ, where they would all show up in the same menu or all show up in the plugins menu. Yeah, here I'm just showing the background removal, and also the label segmentation labeling shows a lot of segmentation algorithms, and you can choose from them. Yeah. Exactly. Okay, good. Yeah, so in the segmentation labeling menu, you find different segmentation algorithms. So what I've shown you before, Gaussian blur, threshold O2, and then applying connected component labeling, that's available as a shortcut. This is like such a common workflow that people use it so often that we thought, okay, we make an extra menu for that. It's called Gauss O2 labeling. And a little bit more advanced, an algorithm called Voronoi O2 labeling is capable of splitting these objects here, which are this H-shaped kind of. This is actually a functionality similar to what we have seen in ImageJ. I think I will come back to this on one of the following slides. Yeah, exactly here. There was a discussion at some point that the Watershed algorithm in ImageJ is actually not a Watershed algorithm, at least from what it does, what it takes as input and what produces its output. So you see here, that's my binary image, my input image, and this is the result. So I'm splitting these H-shaped objects here. I'm splitting them into 2. This is pretty much not exactly the same, but it's very close to what ImageJ's Watershed does. And in Napari, we called it differently. We used the opportunity. We are reprogramming this functionality now for Napari. We would like to give it a better name. Like Watershed was not meaningful, was not kind of correct from an image processing perspective. That's why this tool is called split touching object, which is describing what it does. And you find it in the tools menu under segmentation post-processing. So if you have a segmentation or a binary image and you want to post-process that, you want to edit it, you want to fine-tune it a little bit, then you find in this menu, you find operations. What is more common in ImageJ, so these kind of binary images with split objects is like not so common in the Python ecosystem to work with. You rather work with these label images where every object has a different color. And that's why you find under tool segmentation labeling, you find a label touching object operation. The algorithm behind is pretty much the same, just the output is differently. So you come to a label image in that case, and you come back to a binary image in that case. Just showing some more algorithms in the process label button, which is identical to the label post-processing menu. You also, for example, find this operation where you can dilate labels. I think also this is something that's not available in ImageJ, but some of us always wanted to have. You have the same functionality or functionality which is very close, also in morphological and ImageJ available. Here you also find it in the assistant when it's installed. I think most of your computers will also have it. And this is like, we are now talking about morphological operations on label images. So assume this is your original image. You want to erode these labels and you want to dilate them again so that the outline becomes a bit smoother and you basically get rid of these tiny corners here where nobody actually knows if this segmentation is right in this region. It's called here, it's open. So there's no background. It does not belong to any of these cells anymore. So that's why this is a label opening. We named these operations eroding of labels and dilation of labels. We named it like that, even though it might mathematically not be 100% correct. It was a discussion with David Leblanc at some point. He said, we are the first ones doing this with label images on a larger scale and making it available to the community. So we should give it a name like we think is right. So this is erosion of labels and dilation of labels. You see here in the middle also the opening of labels. Again, it's the same thing I showed on the other slide, and you see that objects are disappearing, and there's a lot of background created when you run this operation. That's why we also implemented smoothing of labels, where you see here the borders become a bit fluid, and you also get rid of these regions here where it's a bit unclear of if this pixel now belongs to the one cell or the other cell. Also, this one we had to give a name. We call it smoothing of labels. So if your segmentation algorithm is not perfect, you can, of course, spend a lot of time in tuning parameters, or you use one of these label post-processing operations, which are available in the Napari Assistant, which you might search in other tools. That's the same tool again, just shown in Napari so that you can see how you can basically visualize your segmentation of these membranes on top of the original membrane, which makes it easy to tune this parameter so that it still fits to the biological parameters. So the Napari Assistant is this user interface you see here also again on the left, is basically an interface on top of multiple other plugins, which bring functionality in there. So just coming back to this question, APOC, the Accelerated Pixel and Object Classifier I showed earlier, brings one or two entries into this interface. And for example, Napari segment blobs and things with membranes, with this very nice short name here, also brings a lot of functionality, which is available in the assistant. The problem is now, or one problem which comes with this kind of, you have different plugins and some work and others don't. So the problem comes now with, for example, device compatibility. So most of the plugins, most of the tools in Napari segment blobs and things with membranes are compatible with most computers I've seen. Napari simple LTK, you see this circle here is a tiny little bit more on the left. So I have seen some exceptional computers where Napari simple LTK does not work. So I think, for example, there was some specific Linux versions where we were not able to make this thing run. And when you use Esperanto and GPU acceleration library and QPy, another one, the device compatibility is really like not as good as for these two. So these two will very likely work on your computer. Esperanto, there are something like 5% or so of the computers where we cannot make it work. And for QPy in particular, you need an NVIDIA graphics card. So why do we develop these things? For a very simple reason. Because if you want to process 3D images, big 3D microscopy image data, you have to have a graphics card. There's hardly any way around. Also, all these modern deep learning libraries all require a graphics card, a dedicated one with a lot of memory, and potentially an expensive one, if you want to process 3D data. For 2D images, I think everything is fine. You have no big deal. You can even run deep learning on small 2D images. But when you go 3D, you unfortunately have to invest a little bit in a computer and a graphics card and get proper modern hardware. So I'm saying it's that explicitly because I would love to make Napari plugins which run everywhere, but the effort is like super high and it may not even be possible in very general. So if you face a three-dimensional image processing problem, segmenting cells in 3D, buy a proper workstation with a graphics card, and then you may have a much easier life. because then these things are compatible. Good. As shown earlier, there's a lot of tools which have duplicated names sometimes, and that's why we also implemented the search here at some point. There's the search field on top, and there you can enter terms. For example, you can enter the library you want to work with. If you are personally friend of Scikit-Image and you have used it before for many years, enter Scikit-Image there, and the assistant buttons will go away where there is no tool available from Scikit-Image. It will only show the tools which come from this particular library. And in that way, you can ensure that the workflow runs on as many computers as possible. Also, if you want to, for example, do one specific thing with your biological sample, you want to do a membrane-based cell segmentation, then enter membrane, and only the functions will show up where the developer was writing in the documentation that this tool is compatible for membrane-based cell segmentation. Also here, if you are a plugin developer, please write good documentation, doc strings of functions in this case, which allow us to conclude what this thing is good for. Yeah, and if you enter something which is not known, then you can click here on the Napari Hub search, on the image SD search, or you can search the Bioimage Informatics Index and find other tools. So if there's no tool available in Napari, you can maybe find a Fitchi plugin or a standalone software which allows you to process this kind of data, and therefore this search field. No, that's a fantastic question. Actually, so while you perceive that updating might be complicated, what you may not perceive, but actually good is the Napari. You sit in front of a Napari and you do some image analysis today, and also this will still work tomorrow because there is no window popping up that something has been updated. If in Fitchi we see that sometimes people update their Fitchi and then suddenly the image analysis doesn't work anymore, this plugin is broken or this macro doesn't execute anymore, and that's actually not so good. And as there is more open source projects happening and more people updating their things all the time, this problem will become bigger with time. So what I would recommend is not updating anything in your Conda environment when you are already working with it, when you are already analyzing data. You have learned today in the session before that you can create Conda environments. And that's what I would recommend. Creating Conda environments becomes a super easy thing after you have done it something like 10 times. And then you just say, okay, I start a new project and I would like to work with the most recent versions of all my plugins and of the Napari itself and so on. So you create a new environment where you install all the new stuff, and then you can in this environment try it out. You can apply your workflow to your data. If everything works, great. But there may be even new features which are fantastic and you can eventually use them. If not, you can just go to the old environment from the other project and can continue working there. And this is in Fitchi not so easy. You can in Fitchi not go back after you updated it. You have to make backups before you update. And this is like, it's basically two paradigms. Update your Fitchi, which is something like an environment, or create a new Conda environment and install everything you need. And in case it's broken, you use the old one. Also, if your old Conda environment broke, and you know how to make it, you can, at any point in time, create a new one with the same configuration. This is hard with Fitchi, and with Conda and Python and Napari, it's very easy. It's the paradigm shift, though. People have to get used to that. Does that answer your question? Thanks for asking. Good. And then we heard it already quite often today, Jupyter Notebooks. You set up an image analysis workflow in Python, and then you can generate a notebook from it. So you here see it for the first time. So I created a notebook from a workflow that was in Napari, and then I can, from this notebook, open Napari again. I will just show it again, and then I think I can also show it live. So you see here, I generate a notebook which shows some Python code. You see here 5 cells of Python code, and I'm executing them. And there's a Napari viewer opening on the left, showing the same segmentation result as we've seen before. I think I will show it live in action in a minute, so you can all watch how I do that. And there is also a written tutorial how you can do this step by step on your own. So this is what we will then do in the next half hour. I think I'm almost through. But this is a cool thing because what people often ask for, they click around in Napari for some time, and at some point you want to know, I have the best segmentation algorithm in front of me, so how can I get this into Python code and apply it to all my other data sets? And this code generator here is one potential solution for this kind of scenario. Yes, So that would be the demo I will show in a second. In case you do not have all these buttons in your assistant, you can later raise your hand and I'm happy to have a look at your computer. Otherwise, there's also a link here of the troubleshooting. Would mean most likely something is wrong with your graphics card drivers. I will show this in action in a minute. And then again, you find these tutorials online and by clicking here on these links. I will just go through my last slide because I would like to thank my people because I can spend my time here preparing slides and talking about it because my fantastic team in Dresden is taking care of the daily business with image analysis and stuff.